Welcome to the lecture series of Computer Networks. I am Harsh Khattar, working as Assistant Professor in Department of Computer Science at KITE Group of Institutions, Ghaziabad. Till now, we have discussed about the physical layer and the network topologies, transmission media. In last lecture, we have discussed about the transmission media. Either we can choose the guided or unguided. I hope you have solved the assignment given in the last class about the guided and unguided media. If you want to prefer for the communication, then there are pros and cons of each and every one. In today's class, we will talk about the switching methods, signal transmission and the encoding schemes. So, what type of switching methods are there? What type of signal transmissions we have? When we talk about the transfer of data from one end to another end, this is a mechanism basically. If I have a data with me and I want to transfer it from my device to another, this is basically the switching of data. Now, this switching of data has various categories, various methods. So, let us have a look about the switching and the switching methods. Very first question is, what exactly switching is? If we talk about the switching, it means the data is traveling from one end to another. So, this is a switching of data bits. So, this technique is known as switching. So, you can see clearly on the screen that the technique of transferring the information from one computer to the another computer is basically the switching. Based on this switching, we have various methods. We can say, yes, this type of switching is through the physical connection, either via guided medium or unguided medium. So, this switching methods are basically three with us. Number one, circuit switching, message switching and packet switching. These are the three main switching methods. Previously, we were using these circuit switching methods. Then we migrated when we have seen the 2.5G GPRS, then we switched over the circuit switching towards the packet switching. Still there are so many areas where we are using the message switching. So, what exactly these switching methods are, what are the differences and what are the examples of these switching methods, we will discuss in this lecture. Circuit switching. Circuit switching, in the layman's language you can understand, if I am calling my friend. So, the phone rings, my friend is answering the phone and a complete loop is formed. So, this looping, I am calling my friend answers the call. So, this is a complete loop. And now, whatever I am saying, hello, how are you, why not you are coming college, where you are traveling. So, these type of questions I am asking and my friend is replying. So, this is the conversation between me and my friend. So, this is under the closed loop. This loop is basically act as a circuit of signal transmission. So, this is known as circuit switching. Okay? So, this is the one basic example to understand what exactly circuit switching is. Now, how this circuit switching forms in the network, in the computer network for the data transmission, let us have a look in technical detail. This type of technique establishes a dedicated path between the sender and receiver. As I said, a complete loop is there between the sender and receiver. So, this dedicated path is formed. Once the connection is established, once the loop is done, once the loop is created, once the bell rings and my friend answered the phone. So, once the connection is established, this dedicated path will remain connected throughout the conversation. So, this dedicated path is generated and the data is traveling over this path only. Okay? In between, for example, during this, due to network problem, if call disconnects, what we are saying, what we are performing, we are calling again to the particular friend and we are saying, yes, I was discussing about this thing, means we are trying to reconnect the network and making the circuit again. So this is how the circuit switching works. So here, so their dedicated path will remain connected until the connection is terminated, like phone call. So in university exam you can write directly, yes, you can call your friend. So this is under the circuit switching. This is the example, well known example of circuit switching. So in this case, a complete end-to-end path must exist before the communication take place. Before sending the signal, means I want to say hello, I am reaching at your place at 5 p.m. But this is my data. Before sending my data, I need to create a path first. First I need to call, I need to listen some rings, and then based on the answerable capacity, based on the speed, after 3 rings, 4 rings or 10 rings, my friend is answering the call. So here this time is basically the delay. This is not a fruitful time where I am transferring my data. In a same manner in computer networks, if my devices are there, so they in between the devices, the first thing is connection establishment. Once the connection is established, only then I am sending my data over the network. So this is how the circuit switching works. In this, the continuous bandwidth usage is required. See one example again. Here, this is one entity A who is sending some sort of message towards B. So in this case, first thing is this connection establishment. So in this, there is a proper connection establishment. Once the connection is established, then the sender can start sending the messages over this. At any case, we can see the connection breaks, then again the complete circuit forms, the connection is established, and then the message will be transferred again. Okay? This is known as connection establishment. Once the data transferring is complete, then the connection termination is the another process, which is the second step of the circuit switching. So this is how the circuit switching works. Now what are the advantages of this? Here, once we have created the circuit, once the connection is established, then no delay is there. All the data packets, all the data streams, all the signals are traveling towards the same path. There is no change of the path once the circuit is found, and we can say the channel is established. Fixed bandwidth, no such variation in bandwidth is required, no further bandwidth is required. Once the connection is established, on the same pace your data is traveling from sender to receiver end and the circuit completes. So this is the advantage. What is the disadvantage? As I said, if the data speed is not appropriate and the circuit breaks. Now what will happen? If the circuit will break, the messages will lose. Suppose I am calling my friend, I am saying, yes, I am reaching at your place at 5 p.m. and my friend is replying, yes, your voice is not audible, your voice is not clear, you are not audible. So in this case, if the message is not delivered at the receiver end, so in this case we can say the circuit is not appropriate. Then I need to cut a call, I need to terminate the circuit and make the circuit established again, and further I am sending the packet, I am again repeating my task, yes, I am reaching at your place at 5 p.m. So this is the best example to understand what is the circuit switching. So this is the disadvantage, it takes long time to establish the connection, during which you can't send any data. During the establishment, suppose it is taking 10 seconds time. So during these 10 seconds, only the connection establishment is there. I can't send any data. So here this 10 second is not productive. If I am talking about the efficiency of a system, if 20% of my time is in the connection establishment, so by default the 80% is the max efficiency. Now out of this 80%, again there is some sort of distortion in the message sending and the speed or the efficiency will degrade. So here this 20% is the wastage of my resources under the connection establishment where I am not sending any fruitful data. So this is the one drawback of circuit switching. It is inefficient to use because once the path is established and no data is transferred, now there is another scenario. You can say, yes, the path is established, I am sending the data, my data is over, path is still established and it is using my bandwidth, it is consuming my bandwidth, I do not have any data to transfer and I am not closing my path. So in this case, my data bandwidth is going waste. So this is inefficient in such cases as well. Another category is the message switching. What exactly message switching is? Now my whole data is divided in form of chunk of data that are the messages. Here no exact creation of circuit is there, no connection establishment is there. The sender is sending the data in the form of messages and the intermediary hops are storing the messages. This is also known as store and forward approach. What it means? Suppose I am sending a data, the data is moving towards one hop, the hop is storing the message packet and then forwarding it further. If the data acknowledgement is not received, again the same message is transferred because the process is store and forward. If I talk about the message switching, the message is transferred as a complete unit. If you have a complete data stream, then the further messages are made and this particular message is now transferred as a complete unit and routed through the intermediary nodes where each node will store the particular message and forward it further based on the number of hops. If in between there are 20 hops, then the particular message is stored at 20 hops. So here all the hops need some buffer to store those messages. Okay, if I am sending some message, then intermediary hops are storing those messages. So again you can see, you can just imagine there is also a security issue. So yes, once you are trying to study, try to understand, you will see the advantages and disadvantages of the method. Yes, the clear advantage is, yes, no circuit is formed, but the disadvantage is you need the storage, extra storage at each hop. In message switching technique, there is no establishment of dedicated path between the sender and receiver. Yes, you can send the message from any node, any hop, and each hop is storing the particular message. Each and every node stores the entire message and then forward it to the next. As I said, yes, we need a special storage for this and this is also known as store and forward network. So this is all about the message switching. If I talk about the advantages and disadvantages, you can just imagine this scenario that yes, the first message goes from this route and then might be there is some network congestion and another packet is moving from the different road. Yes, and all the intermediary hops like the message 2 is moving from S1. So S1 is storing a particular message, then it is moving towards S2. Yes, S2 is saving this particular message, S3 is saving it, S4 is saving it. So at every particular hop the particular message is stored. So that's why it is store and forward mechanism. So here you can see the advantage is basically that no specific data connection is maintained, no specific circuit is maintained, no specific connection establishment is there, but the disadvantage is you need a buffer at each particular hop for this. Another one is the packet switching. What is the mean of packet? As I said in the introduction part, that the packet switching is nowadays it is very common. After 2.5G means when the GPRS came, we are using the packet switching very frequently. It means we are paying only for the packet which we are transferring. So there is less wastage of the bandwidth, less wastage of the frequencies. So how the packet switching is working here? The packet says that data is divided into the packets as we have seen in messages. But what is the difference between the message and the packet? Message can be of variable size, the packet is of same size. Suppose your message is say 100 words long, in the your data is 100 words long, the first message is say 10 words, another message is 2 words, another message is 50 words. So, there is a variable length packet, that is a message. Packet says yes, your data is divided into equal size packet. Another difference is that the packet is storing the information like source address, destination address, because the packet can follow any of the route through any of the particular node. You can see here that this is a series of packets, and these two packets are moving from this route and these two packets are moving from this route. So, the same route can be followed by the multiple packets. Each packet has the source address, destination address. Generally, we are talking about the packet switching happens at the third layer, because we are talking in the introduction of the OSI model, we have seen in the network layer the IP address, source and destination address is there. So, the same concept is used here in the packet switching. In the layer 3 packet switching is used. So, this is one of the interesting and important method of switching the data. So, in this case these two packets are moving from this side, and in between if one of the packet loss and in a specific duration we are not getting the acknowledgement. So, the same packet will be retransfer. So, here the stream of data is converted into the packets, and suppose the packet 4 is lost, then this packet 4, only this packet 4, not the other packets, will transfer again. So, this is how the packet switching works. So, this is very important method in university exam. Out of the 3, this is a very important one. Advantages, yes, it is cost effective, it is reliable, it is efficient. Disadvantage, when we talk about the disadvantage, what is the disadvantage according to you? For each packet you are adding the source as well as the destination address, which is storing some sort of information in the form of signal, in the form of bits. Like each layer is adding the header. So, here in the header we have the information of source and destination. For following the packet switching, the protocols which we are using, the rules which we are defining are bit complex than the message switching and the circuit switching. So, this is the another important flaw in this packet switching. The implementation cost is also very high. In which form? In terms of the time which we are consuming in this. The data which is roaming in the packet is there in a particular network. If you will see this diagram, so one packet is traveling here. Suppose a specific destination is not met. So, in this case a particular packet number say 1 is traveling via all the nodes, and we need to add here the time to live, that after 3 seconds or after a particular time interval the particular packet will automatically destroy or damage. If a packet is roaming inside the network, it is consuming the bandwidth. So, this is the not cost effective formula. So, here we need to add some remedies to avoid this sort of problem. So, this is again an important point. Apart from this, yes, if a particular network is overloaded, already there are so many packets who are traveling in the network. So, in this case this sort of switching will create congestion, and then we need extra congestion control mechanism. Suppose we are talking about in the busy hours, say 6 p.m. we are seeing on the main roads there are so many cars, there are so many vehicles which are on the road. So, in this case the congestion chances are more. The same case is here. If already the bandwidth is completely consumed and the sender is unaware about this, we are unaware about the road, that yes, how many vehicles are there already on the road, and yes, we are also driving a car. So, in this case we are stuck in the traffic. The same case is there with the packet switching, that we are just following here and there the routes, and if in one route we are finding the congestion, we are moving towards the another lane, and yes, again there is a stuck in the jam. So, this sort of mechanism you can assume here in the packet switching, and due to this you can see the packets start corrupting, and due to this overloading of the packets the network is stuck. So, here we need some extra effort, which is a congestion control mechanism. So, this is all about the packet switching. Now, the signal transmission. Signal transmission is the another part. Once we have decided to follow either a circuit switch, message switch or the packet switch, we have decided. Suppose I am preferring the packet switching. Now, in this case of packet switching, which type of transmission I am preferring? My signal is either an analog signal or digital signal, because based on the signal transmission, what signal I am choosing for the transmission, the switching is very important. Suppose I am using the analog signal, so in this case I can't use the packet switching, because the packet switching is only for the digital transmission signals. Okay? So, here it is one of the prerequisite when you are starting developing a model, then which transmission type you are selecting, which switching method you are selecting, which topology you are selecting, which type of network you have, which type of devices you are using. So, these all things are very important. That is why it is added in the first unit of computer networks, that first thing is you are understanding about all the basic functionalities, and then one by one we are adding it towards the complete network and making our whole network as a full-fledged data transmission successful part. So, first thing about the signal transmission is what exactly transmission is. As we have seen what is switching, what is the data transmission. So, there is a interrelated terminology. So, here in this, if we are transferring a data from one end to the another end, so this is the digital transmission. If I am using the word data, means the transmission of data, means digital transmission. If I am saying yes, the transmission of signal from one end to another, this is a normal transmission. Okay? So, the signal can be of analog as well as digital. Okay? So, these are some interrelated terminologies. Might be you will get confused that what is switching, what is transmission, what is sending of the packet. So, yes, the terminologies seem similar, but the definition is different. So, if I talk about what exactly transmission is, so transmission is a process of sending and propagating the signals, okay, using wired or wireless transmission medium. Now, here I have mentioned the term signal. I have not used either it is an analog signal or digital signal. So, based on our functionality, which type of network we are using, which type of resources we have, we can opt for the analog or digital signal. So, typically we can say yes, the signals are of two types, analog and digital. What exactly analog signal is? Analog signal means when my data is traveling in the continuous manner, the sinusoidal wave is formed, then these type of signals are known as analog signals. Previously, if I talk about 3 decades back, 4 decades back, all the signals transmission are through the analog signals. Still there are so many areas, so many applications where we are using the conversion of signals, means I have a digital data and then the data is converted towards the analog signal. So, for this analog to digital converter is required or digital to analog converter is required for this. So, again it depends on your application, which type of application you are using, which type of data you have, and then which type of signal you want for the transmission purpose. So, specifically if I talk about the analog signal, the communication which involves the analog signal, and this signal is continuously vary with time. So, you have seen this type of sinusoidal wave is there and the signal is moving, and here the oscillations are done. So, based on this, the frequency and this amplitude plays a very important role in this. So, this is analog transmission. The examples are, you can see in the previous ones that the transmission of radio signals in the television broadcast, previously we were using the analog signals. Next is the digital transmission. This digital transmission, nowadays we are using this digital transmission. Here the data is transferred in the form of 0 and 1, in the form of bits, and the signal is having the discrete values, discrete interval of time. The signal is like this. Here this peak is 1 and this fall is 0. So, in the next class we will talk about the encoding schemes and you will see about the digital transmission. Nowadays we are using everywhere digital signals. So, if I talk about the summary and the two open end questions from the today's class is, if you are making your own network, which type of switching method you will select. So, we have studied circuit switching, we have studied message switching, we have studied the packet switching. Out of this, which one you are opting for your own network. Similarly, which type of signal you will opt for, either analog signal or digital signal. So, this is all about the today's class. In next class, we will start the encoding schemes on over the digital signals and then ISDN.